Okay, pause the video here in a second and copy down the Roman numerals from 1 to 10. We're going to need them because now we're going to look at naming and formula writing for ionic compounds that contain transition metals. So unlike the metals that we've looked at so far from groups 1, 2, and 13, where only one possible charge was present, we'll notice that on your periodic table, if you have a look at the boxes for the ions in the transition metal section, we notice that many of them have more than one possible ion that they can make. So this makes pairing up with the anions that we're already familiar with not hard, but just a little bit more work in ensuring we have the right formulas. So let's have a look. Two compounds, CuBr and CuBr2. They follow the same cation anion format that we're used to, and we notice that copper can be either 1 or 2 positive. We know that bromine, or the bromide ion as it's known, always makes a charge of -1. So remembering that when an ionic compound is formed, some of the charges must equal 0, we can work backwards to determine which copper ion is present in which species. So we'll draw some bromides, and we can see the CuBr compound. When there's a single copper present with the bromide, the charge sums to 0, whereas we need 2 bromide ions for every copper in the CuBr2 compound. So in order to name these, we say copper 1 bromide and copper 2 bromide, where the Roman numerals 1 and 2 refer to the charges on the copper ions shown in the red and yellow circles respectively. So it's those Roman numerals that I asked you to copy down at the beginning of this video that will tell you in a name which charge is being used for a particular transition metal ion. So now we're going to have a look at another example where we will take a name and we're going to turn this into a formula. So the compound we're going to work with is manganese 7 selenide, and I've got it color coded here for you. You'll notice maybe that selenide found on your periodic table has a charge of -2, but if we were to zoom in on the box for manganese, we notice that 7+ doesn't appear to be an option. Don't be afraid of this. There's many charges on the transition metals that aren't shown on our periodic table, so let's work through this problem and assign the formula nonetheless. So the 7 on the manganese refers to a 7 positive. Selenide is always 2 negative, so we can see the overall charge change as I add more selenide ions, and then I add another manganese ion into the mix as well. So we can see that once I have 7 selenides and 2 manganese 7 ions, I get an overall charge of 0. Therefore, the formula of the compound is Mn2Se7.